As a result of temperature and heat, energy, objects in general expand, whether it is solid, whether it is liquid, whether it is gas. This is the general rule of thumb. The expansion means the dimensions will increase as the temperature increases. Because of that, you see here, I'm sure you are all familiar with this, on bridges, you will find sections. The bridge, you will find it made of sections separated from each other like this to allow for thermal expansion, such that during the hot season, when the bridge expands, it has this free space to accommodate the expansion. Without having this kind of space, the bridge will collapse. It will break due to thermal expansion. The same applies also to what we do in buildings, whether it is the sideway or whether it is the wall or you name it. We need always to allow for thermal expansions. If we did not allow for thermal expansion, then damage can occur. The reason behind thermal expansion is the structure of matter, as you can see in this illustration. The atoms inside the molecules are in continuous vibrations and oscillations. We model them with these springs. When you heat the material, the oscillation amplitude becomes bigger and bigger, and therefore the space needed to accommodate the oscillations for each atom will be bigger, and overall this will result in change in the dimensions. This will result in expansion as we heat the object. If you have an object with length L naught at temperature T naught, if you raise the temperature to T, then there will be a change in the length delta L, which is dependent on the original length and on the change in temperature. Okay? Delta L is proportional directly with L naught and delta T. We change proportionality into a formula, into an equation. We will need a constant. The constant here is alpha. It is called the thermal coefficient of expansion. So here you see some common materials and the value of this average coefficient of linear expansion. Okay, by average coefficient of linear expansions, we mean the change in length per degree Celsius. Okay, so here you have it for aluminum, 24 by 10 to the minus 6. For concrete, 12 by 10 to the minus 6. For steel, 11 by 10 to the minus 6. Here for some liquids, like for benzene, it is 1.24 by 10 to the minus 4. For mercury, 1.8 by 10 to the minus 4. For gasoline, 9.6 by 10 to the minus 4. Okay. For air, gases also expand, as you can see here, just like liquids and solids. So we need to be aware of this behavior of all materials and to take it into consideration in any design that we make. This is the explanation for the problem that we had at the beginning of the lecture. When you have a hole, the hole will expand, the whole area will expand when you heat the object. So not only the solid part, but also the cavity will expand. The surface expansion, here, you need to take the equation for the linear expansion and multiply it by the other dimension. Because that, for surface expansion, we have to deal with 2 alpha. So the new area is equal to the old area plus 2 alpha multiplied by the original area and by the change in temperature. Okay, so if it's 2-dimension, you have 2 alpha. If it's 3 dimensions, by the same argument, you will have to use 3 alpha instead of 2 alpha. In this table, we see some useful information. Okay, for volume expansion, the coefficient is a 3 alpha. We call it beta. And when you deal with volume expansion, this is especially important for fluids, liquids, gases. In that case, the change in the volume is equal to beta multiplied by the original volume by the change in temperature. And beta is just 3 alpha. So for aluminum, if you have aluminum rod, it is 24 by 10 to the 6. But if you have aluminum cube or sphere, 3-dimensional object, you multiply this by 3, so it becomes 72 by 10 to the minus 6, and so on and so forth. Now, time for you to check your understanding. If you quickly plunge a room temperature mercury thermometer into very hot water, the mercury level will. You have these 3 possibilities. Please read and then share with me and the class. What do you think? Your thoughts?
I think it would be number 1. It will expand and then reach the final.
So you think it will go up briefly before reaching a final readings?
I think it'll go down.
What made you say that? What is the logic behind this, behind your answer?
If you quickly plunge.
Look, the system is composed of 3 things.
Yeah.
You have the mercury. The mercury is liquid, so the mercury needs a container. The mercury is inside a glass container, right? And then the third object is the liquid, the hot water, right? So because of hot water, a glass will expand, because glass is the first object that is facing water. Then heat has to transfer through glass to the mercury. So the mercury will need some longer time to respond. Okay? Does that make sense?
Yeah.
So what do you think of this option?
Yeah, number 2 is better.
Yeah, go down briefly.
Right? Yeah, because glass will expand at the beginning, will expand more than mercury. Simply, mercury did not feel the heat yet. Okay? But once the heat is transferred, because heat transfer requires time. Once enough time has passed and temperature transferred through glass, then yes, mercury will expand more than glass and it will increase going up. Yeah, this makes sense. Another question. If you are asked to make a very sensitive thermometer, which of the following working fluids you choose? Mercury, alcohol, gasoline, or glycerine? To answer this question, we need to go back to the table here. This is the thermal expansion of gasoline, 9.6. For acetone, it is 1.5. For glycerine, it is 4.85. And for mercury, it is 1.82. Okay? Keep this in mind in order to answer the question. So which fluid you will choose? You need something that is really sensitive. In other words, the coefficient of thermal expansion needs to be the highest, so that you can check on the slightest change in temperature. Shall I go back to the table? So which is the one with the highest coefficient of thermal expansion?
It will be gasoline, right?
Right?
Yeah.
Do we agree on that? So 9.6 is greater than 4.8, greater than 1.8, and greater than 1.5, right? Gasoline would be the most sensitive because it will respond to any change, to the slightest change in temperature, better than the other two fluids. Okay? Gasoline has the highest coefficient of expansion, so it undergoes the greatest change in volume per degree change in temperature. Yes, we will choose gasoline. Another question. Two spheres are made of the same metal and have the same radius, but one is hollow and the other is solid. The spheres are taking through the same temperature increase. Which sphere expands more? What do you think?
Is it the hollow sphere?
The hollow sphere. Why do you say the hollow sphere?
There's less metal, so it's
Okay.
not going to take very long to heat the whole thing and have that expand, rather
Okay.
than having the solid sphere. It's going to take longer, possibly.
Okay. Class, do we agree on this? Let me take you back to something, to this equation. If the original volume is the same, and the change in temperature is the same, and beta is the same, because it is the same material, then delta V will be the same, right? It all depends on the original volume. We don't care whether it is hollow or whether it is solid. Just like the ring that we discussed earlier. So from this equation, we understand that the right answer is this. They expand by the same amount. We don't care whether it is solid or empty from the inside. Okay?
Makes sense. Thank you.
So yeah, a cavity in a material expands in the same way as if the cavity were filled with the surrounding material. Okay, this one. Why doesn't the melting of ocean-based ice raise as much concern as the melting of the land-based ice? This is a very deep question. I want you to think thoroughly before answering. Take your time.
Would it be 1?
We all agree with that? Yes, it is 1. Because the ice that is in the ocean, it is already in the ocean. And it's not going to cause flooding if it melts down. But the ice that is on the land, if it melts down, then you will face a flooding. It would be an additional water coming to the ocean that will raise the level of the water, right? You are simply adding huge amount of water to the sea or to the ocean. So yes, that would be the main concern. Thank you. As I said, all materials will expand when you heat them. The only exception is water. If you cool water down, like ice, the density becomes less. If you heat it more than 4 degrees, okay, so the volume is inversely proportional with the density. That is to say, when the density here is maximum, the volume would be minimum, okay? And then it will follow here a linear change with temperature, and also here linear change with temperature. This is a great blessing, because when you cool water, change it to ice, the density becomes less, and therefore we end up with a layer of ice at the surface that isolates the rest of the water from the cold weather, and that way life continues underneath that layer of ice. Because ice is less dense than water, it floats on the surface of water. If it was the same density, it will sink down, right? So because of this property of ice, the density of ice is less than the density of water, then the upper surface of water will get frozen during the cold season, and it will isolate the other layers of the water. It will protect life in these layers, okay, and life will continue. This is a nice thing to take note of when we learn about the ecosystem around us and how the equilibrium, how the balance between various things is achieved.